A school buys uniforms that are embroidered with the school logo, so that each uniform costs money, and the setup of the embroidering machines costs money. So embroidering is when you put sew in a logo onto some clothing. And the charges are shown here. So we have 10 uniforms, the charge is going to be $199. 20 uniforms, the charge is going to be $358, 25, etc. So we want to figure out the charge for 105 uniforms. Now, we could come up with the equation and do this. Anyway, whatever we're going to do, we need to know basically how this progresses. And it would be nice to know the initial setup charge as well. So each uniform costs money. So that is going to be a rate of cost per uniform. Okay, so that's my change in Y over the change in X. So I'm just going to look for that cost per uniform as a slope on the outside of my table. So I have plus 10 uniforms, and that's going to cost, using my calculator here, that's going to be 159, it looks like. 358 minus 199, $159. So 10 uniforms costs $159. So it looks like the rate is going to be $15.90 per uniform. So if I want to find the charge for 105 uniforms, well, I can just go up to, go plus 50 here, and then 50 uniforms would cost, should cost times that by 5, so I'm going to end up with plus 795. So that's going to be 100 uniforms would cost $16.30, and then I just need 5 more uniforms, so plus 5 at $15.90 each. So 15.9 times 5. That's I'm just gonna add another $79.50. Okay, so 1630 plus 79.50. It's gonna give me $1709.5 or 50 cents. Okay, so we could use this basically what I'm doing on the outside is finding the cost per uniform, okay, or the rate of change, or essentially the slope. Now, if I find I can really just come up with the equation of the line here. So to find the charge for 105 uniforms, I don't really need to do that. I can set up my equation. So my charge Y is equal to, well, I can work out my slope. I'm going to just do that over here. My slope was my change in Y divided by change in X. My original change I calculated was $159 for 10 uniforms. So we worked it out to $15.90 per uniform. Okay, so I'm going to go 15.9 times X plus, we need to know the initial setup charge. So if we want to figure that out, essentially we're solving for B, our Y-intercept. How do I solve for B? Remember, I'm going to find my slope first, and then I need to plug in a coordinate that allows me to solve for B. So I'm going to take one of these coordinates. I'm going to take the first one, $199, and I'm going to plug that in for X and Y. $199 and 10 uniforms. So 199 is going to be 15.9 times 10 plus B. And so this allows me then to come up with an equation that I can solve for the Y-intercept. So my B value, when I work this out, is going to be 199 minus $159, and that gives me a B value of $40. Okay, so my equation of the equation here works out to be 15.9x plus an initial $40 setup charge. So I could have done it off my table like this. In fact, if we really wanted to, we could have found our B value based on this table, because if I go plus 10, I can also go minus 10 to 0. And notice that that would then subtract 159, and I would get my $40, my B value of $40 in that way. At x equals 0, y equals $40. Okay, so I can use this slope in the backward way to get my y-intercept. And then using this equation, my input is 105 uniforms times the cost for each uniform. And then I'm going to add the $40 setup charge, and I'm going to end up with 15.9 times 105 plus the $40 setup charge gives me the $17.09.50. Okay, so this is probably a much more efficient way to do this problem, finding the charge, is actually work out, since we have the table of values, we can work out the slope, we can work out the y-intercept, we can then work out the equation of this line, of the relationship, and then we can use that relationship to calculate the y value given x. Okay, so this is kind of a good way to do it. So we can, I'm going to just sketch the graph in here. You can plot this into, your Desmos and do that as well. I'm just going to sketch a graph like this. So my looks like I'm going to maybe go up to $1,000 of charge. Maybe we'll go to 50 uniforms. Okay, so 50 uniforms were about 8 something, 30, so 20, 30, 20, 10, so 30 uniforms, maybe we're at 8 something, or sorry, 500 and something, so somewhere around here. Okay, and 20 uniforms, we're at 300 and something around here. Okay, and we have this relationship that goes from 40 up like that. Okay, and so if you're graphing on this graphing window, we don't actually need to label this graphing window. What we can do is we can just say our x min is maybe -10, our y max is 60, here our x min is maybe -100, and our y max is 1,000. And that way we don't need to actually write in our scale right into our graph. Okay, this is what this window is for. It's not a bad idea to write in the scale though, so if you want to just leave that in, go ahead and leave that in. Okay, so the school plans to spend $1,000 on uniforms. So it looks like $1,000 on the uniforms is going to be somewhere around here. It's going to be more than 50, so it's maybe about 60 uniforms or so. We can see that directly from our graph. We can also calculate this based on our equation. So I know the y, I know the output, I'm being asked to figure out the input, so I need to solve or undo. Okay, so I'm going to subtract 40 from both sides. I'm going to divide by 15.9. And I get an x value of, so 960 divided by 15.9. That gives me 60.377. So I'm just going to round that to 38 uniforms. Okay, so how many could they buy? Well, they can't buy part of a uniform, so they won't spend the full $1,000, and they'll end up buying 60 uniforms. So what is the cost of each uniform? What is the setup charge for the embroidery machine? Well, the cost per uniform is our slope. Okay, so our slope was $15.90 per uniform. Okay, the setup charge, so that is the cost for each uniform. And the setup charge is going to be our initial charge, or y-intercept. The y-intercept was $40. Okay, so that's the initial charge, or the fixed amount, which was our $40 that we calculated.